Okay guys, welcome back. So today we're going to be looking at mesh current method. So in this example, we're going to be revisiting the same circuit with nodal analysis, and I want to talk about efficiency between the two circuits. So in some cases it might be more efficient to solve this using nodal method versus mesh, but we're going to visit both. For this mesh example, I'm going to walk you through the algebra of how we're going to organize our equations. However, in the nodal example, I'd like for you to go ahead and solve the algebra on that and organize it into the matrix format. As in my previous videos, I've mentioned that the harder part of this is going to be organizing your equations. If you can get your equations organized, that is a bulk of what you need to do. All right, so without further ado, let's begin. So I see that I have my IA right here, my IB, and my IC, and my ID, which I've defined right here. So when looking at these circuits, I realize that I have a whole bunch of sources and things can get kind of confusing very fast if I'm not organized. All right, so what I want to do is take a look at V naught right here. V naught is going to be expressed as a potential difference. Sorry, not potential difference. It's going to be organized as Ohm's law, all right? I want to model Ohm's law. So in order to do that, I'm going to say V is equal to Ri. So I'm going to say V naught equals to my 250, my R times my IA minus my IB. Why am I doing that? Because my IA is coming through the positive terminal, my IB is coming through the negative terminal. All right, so that's one thing I want to keep in mind when I'm going through. And I want to see my V delta. Now, V delta in this circuit, just like how we did for V naught, V delta is going to be some R, 500 ohm, times IB minus IC. All right, my current coming in through the positive, current coming in through the negative. So without further ado, let's go ahead and start writing these equations. So I'm going to write my mesh for IA. I'm going to say that I have minus 20 plus 250 IA minus IB plus 1000 IA equal to 0. My mesh for IC is going to be 500 IC minus IB minus 0.4 V naught plus 200 IC equals to 0. And I just want you guys to look at this guy right here. We're going to be revisiting it just shortly, okay? Now I do have a constraint 1. I'm going to call that constraint 1. Now my constraint equation is going to come from my source, all right? My first constraint is going to read as ID minus IB equals to 200 milliamp. Now if you're confused on where that came from, that's going to be this source right here, all right? So when I have my currents like this, I want you guys to think in terms of it's going in the same direction as blank. So in this case, I see my current source enforcing 200 milliamps in this direction at all times. Just like day one rules, it's going to be enforcing it at all times. So my current that's going in the direction of this is going to be ID. My current opposing that is going to be IB. Now these are what I've labeled. If you choose to do your currents in the opposite direction, you need to account for that in your equations. All right, that's where the first constraint comes from. My second constraint, C2. C2 is going to read as ID equals to 0.003 V delta. Now, whenever I see this V delta, it doesn't match any of my currents that I want. So in my head, I want to think, what the heck is V delta? Well, V delta, as we defined before, is going to be 500 IB minus IC. All right, and we're going to revisit that when we write our equations out. Let's go ahead with the first equation. We're going to have minus 20 plus 250 IA minus 250 IB plus 1000 IA equal to 0. All right, organizing this, we're going to end up getting 350 IA minus 250 IB plus 0 IC plus 0 ID equals to 20. Now you don't have to include the zeros. I just like to do it as a placeholder. So this will be my first one, let's go ahead and highlight this. We're going to need this for when we plug it into the matrix. All right, so my next one is going to read as 500 IC minus 500 IB minus 100 IA plus 100 IB plus 200 IC. Now, where am I getting these numbers from? So, like I said before, V naught is going to equal to 250 IA minus IB. When I do my 250 times my 0.4, I'm going to get 100. Therefore, I can go ahead and model it out with these equations. And this is all going to be equal to 0. All right. So for my constraint 1, I see the ID minus IB is equal to 200 milliamp. I can go ahead and say right away that ID is equal to 0.003 V delta, or I can choose to leave it in the form that it is right now. Doing that, I'm going to get 0 IA minus 1 IB. Oops, let's make this a little bit neater. Minus 1 IB plus 0 IC plus 1 ID equals to 200 milliamp. My second constraint is going to read as, let's go ahead and revisit this, V delta. So V delta is going to equal to my 500 IB minus IC. So multiplying that 0.003 times my 500 and distributing out, I'm going to get something that reads as 0 IA plus 1.5 IB minus 1.5 IC minus 1 ID equals to 0. All right, let's go ahead and organize these equations. Alrighty. Oh, sorry, we're not done with this one yet. We haven't distributed this guy. Let's go ahead and distribute out. So we're actually going to end up getting minus 100 IA minus 400 IB after collecting terms plus 700 IC plus 0 ID. Now, please don't make the same mistake that I did and skip straight to plugging in. Let's make sure that we have everything correct first. All right, so now we can go ahead and highlight this. This will be our final term that we're going to enter into the matrix. This term right here, I have no more simplification to do. I'm going to go ahead and highlight this to be entered. This term right here, I have no more simplification. So let's go ahead and highlight it in to get it ready to be entered into the matrix. Alrighty, so what I'm going to be doing now is entering my terms as is. I'm going to model IA, IB, IC, and ID. All right, so entering it, I'm going to have 350 minus 250, 0, and 0. I'm going to have minus 100, minus 400, plus 700, and 0. I'm going to have 0, negative 1, 0, and 1. I'm going to have 0, 1.5, negative 1.5, and negative 1. All right, let's go ahead and bring this term down and reduce it a little bit. All right. So that we're gonna, in our calculators, we're able to model this and get exact solutions for it. And we should see that we can model it with its solution. So we're gonna end up getting 20 on this side. We're gonna end up getting this equal to 0. This is gonna be 200 milliamp, and this will be 0. All right, and plugging it into our calculator, let's just go ahead and make sure that we're able to get the right solutions. All right, so after entering it into our calculator, we're going to see that we get IA equals to negative 240 milliamp. IB is going to equal to negative 416 milliamp. IC will equal to negative 272 milliamp, and ID is going to equal to negative 216 milliamp. With that being said, we can go ahead and evaluate the power. The power is going to be equaling the 20 volt, which is going to read as my 20 ID minus IA, which equals to 20 times my negative 0.216. If we want to keep it in amps, plus my 0.24, and that should give me a value of 0.48 watt